Hey guys, so we're going to look at 4.6 part 2. We're starting with the horizontal line test. So it says the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. So I'm going to look at this first graph here where the horizontal line, the red line here, it looks like it hits one time and that's pretty much it. So that is no more than once. This one is a function. This other one hits, the horizontal line hits more than once. So this one is not a function. Not the original graph, but the inverse either is or is not a function based off of how many points that horizontal line hits. Okay, so let's graphically, let's look at it algebraically. So determine whether the inverse of each function is a function, then define the inverse, then find the inverse. So if I want to figure out if this even is a function, I'm going to consider this parent function, x cubed, and they've done some transformations on it, but my parent function, the cubic function, looks like this, which no matter what horizontal line I draw on that, it'll only hit once. So this inverse should actually be a function. I'm going to say, yes, this is a function. But I was just thinking graphically, and I didn't even have to graph the exact one. I was looking at the parent function. And based off of that, my inverse will be a function. So I'll write specifically inverse function. All right, so let's find the inverse. To find the inverse, I swap my x and y. I'm going to treat this like it says y equals instead of f of x equals, and I'm going to swap the x and y to where it now says x equals 2 times y cubed plus 1, and this should look pretty familiar to what we did yesterday. I'm then going to solve for the y. So if I subtract 1 from each side, I then divide by 2 on each side. All right, I'm going to move this over here. And now I'm going to do a cube root of each side, and I mean like the entire side. So my cube root, cube exponent, gone just for a y. All right, and here's my cube root of x minus 1 over 2. All right, now I was finding the inverse function. I solved for the y, and I'm now going to replace that y. Like, you know how I had the y in the place of an f of x? So this y now is actually representing my f inverse of x. That was because I swapped the x and y. This is now my f inverse. Okay, and it is an inverse function. All right, so let's do the same thing here on number 2. We are going to determine whether the inverse of each function actually is a function. So I am going to consider my square root graph that looks something like this. Again, I'm thinking of just the parent function, just the square root of x. And if I do a bunch of horizontal lines on this, I think it only hits once. Even this top one, it hits only once. And then the curve continues on. But each of these horizontal lines hits only once, which means that my inverse will actually be a function. All right, so now let's find that inverse. Again, it's a g of x instead of an f of x, but whatever, I'm going to treat it like a y, to where I swap my x and y. So x equals, instead of y equals, 2 times the square root of y minus 3, instead of 2 times the square root of x minus 3. So I swapped my x and y. I now have to solve for the y. So I'm going to divide by 2 on both sides. Okay, and then I need to square both sides to get rid of my square root. Square root, squared exponent, those are inverses, totally gone. Now, keep in mind, I had to square like the entire side of the equation. So put some parentheses around that. The x is squared and the 2 is squared. In fact, because the x is squared and the 2 is squared, I can treat it as an x squared over 4. All right, equals the y minus 3. And then I will add 3 to both sides. And I get this x squared over 4 plus 3 all equals my y, which again, I'm gonna, instead of putting an f of x for my y, I'm doing f inverse of x. The whole way that I solved for this was by replacing my x and y. So this is my f inverse function. Actually, I think we had a g of x, so I'm actually gonna call this a g inverse. we go. So there's my g inverse function. All right, so if you guys are ready for this, go ahead and pause, try out number 3, and then you can turn it back on and see if we got the same thing. All right, so to decide if this is an inverse function or not, I am again looking at my parent function, which is the x squared, which is like a parabola. It's a negative x squared, so it's like facing down, but regardless, I'm thinking of a parabola. And would that pass the horizontal line test? I actually have an example of that up here. This parabola, even if it was facing down, it does not pass the horizontal line test. It would hit more than 1 point. A horizontal line would hit more than 1 point. So this one is not an inverse function. Okay. Again, I'm looking at my graph and my horizontal line hits more than once, which means not a horizontal line test. And now I'm still going to find the inverse. It's just not going to be an inverse function. All right, so to find my inverse. Oh, wait, I take this back. Okay, sorry, rewind. Let me show you what I'm talking about. The restriction. We have not talked about this restriction right here. We talked about it last time, but today let's remind ourselves that's a restriction on the domain, which usually this parabola, this is a reflected down parabola right here, and it has the little arrows like it goes forever in both directions, but they want the portion of this where the x's are greater than or equal to 0. So that's like this side, or where the x's are greater than or equal, or sorry, less than or equal to. So we're going to go with these guys, and basically the negatives are less than or equal to 0. So it's like this half of my graph. So if I'm just considering that half of my graph, these horizontal lines hit these negatives only once, only once, only once. It would hit, if it was looking at the other side, it would hit more than once. But I think this is what we looked at on our notes yesterday. I'm considering half of this guy, and my horizontal lines hit only once on that part of the graph. So this restriction right here, that restriction actually makes it so it is an inverse function. So I'm going to erase this. This one is an inverse function. Okay, so then that means we'll have to have a restriction on the inverse. So I'm going to solve it like I did before. Instead of h of x, I'm treating it like a y. And then I swap my x and y. So x equals a negative y squared. I'm going to solve for the y, so I will divide by negative 1 on both sides, basically change the sign on both sides. So I get my positive y squared. And then I square root both sides. So I'm going to go with a negative x under my square root, and this all equals the y. Now I had originally an h of x function, so this is now my h inverse of x. Okay, and you know how there was a restriction? Your domain on this other one had to be everything less than or equal to 0. Okay, so I'm going to change this to, x's and y's. This is going to then have y's are all less than or equal to 0, but it's the same section. If my y's are less than or equal to 0, this is still going to be that same part of the graph. All right, so I swapped my x's and y's. So here's my new restriction. And this one is my inverse function. Okay. So now let's see if we can determine the ones they gave us, determine if those are inverse functions or not. So it's not like I have to find the inverse function. They're giving me two, and they're thinking, okay, these could be inverses. Let's check and see. So here's my kind of big idea here. My f of g, I guess I need to check the g, but f of f inverse equals just a straight up x. Or if I did the inverse, if I did f inverse of f of x, that also equals just a straight up x. So this is going to be what I'm checking here. So when I say f of something, that means I'm going to sub that into the function. So I'm going to take this entire, I'll do the f of g of x first. I'm going to take the entire g of x function and I'm going to sub it into the f. So this whole thing goes in for my f function. I get a 3 times the x plus 1 over 3. So there's my whole g of x, replace the x, and then minus 1. All right, so I'm going to simplify this down, and if it is an inverse, it'll be like it says in the box here, it'll all end up equaling just a straight up x. So let's see, 3 divided by 3, those divide out. I'm down to x plus 1 minus 1. And then plus 1 and minus 1, again, those add up to 0. So I am down to a straight up x. Awesome. So halfway through, this one, check. This one's good. Let's now do the opposite direction. I'm going to do my, instead of f of g, I'm going to do g of f of x. Okay, so again, f of x is in the middle, like I subbed that into my g function. So I'm going to take this whole f function and I'm going to sub it into the g function. So instead of an x plus 1, I'm going to do the whole 3x minus 1, the whole f function plus 1, and then all over 3. Okay, so again, I'm trying to see if this ends up equaling x or not. So I'm going to simplify this down. I do have a minus 1 and a plus 1. Those add up to 0. I'm down to a 3x over 3, which the 3's divide out. So I am at a plane x now. So because this is true for both, I'm going to check that one as well. It was true for both. So yes, these are inverse functions. Both of those statements had to be true, and they were. So yes, these are inverse functions. All right, let's try it out on the next one here. We are going to do, again, our f of g of x and the g of f of x. We got to do both. And if they both end up equaling just straight up x, then true, they are inverse functions, which it kind of looks like they might. Like if you look up here, I was multiplying by 3 and this one was dividing by 3, which are opposites. Okay, this one had a minus 1, this one had a plus 1. And so they kind of undid each other. They ended up being inverse functions, which this kind of looks like it too. I've got like a cube root and a cubed exponent. These look like inverses. So let's check this out and make sure. I'm going to take my g of x function and sub it into the f function. So I'm going to take this whole, the g of x, like cube root of 2x, I'm going to put that into my f function. So this will be 8 times, instead of x cubed, I'm putting this whole function, the cube root of 2x, I'm putting that whole thing in for my x. Okay, so to simplify, I've got a cube root and a cube exponent. All right, looking good, looking good. I've got 8 times 2x left. 8 times 2 is 16. I got a 16x. This was supposed to equal just plain x, like a 1x. This one equals 16x. So no, I don't even have to look at this one. This one, it would have to make both of these true. And I just found one of them that is not true. So for that reason, no, these are not inverse functions. Okay. And next up, we are going to look at this word problem here. Find the inverse function that represents the surface area of a sphere. And here's the surface area equation. So to do the inverse of this, we are going to swap the, not x and y, but the r and the s. Okay, so we swapped your input and output. They're not x and a y, but that's okay. We swapped, and then we're going to solve for the s this time. So I will divide everything by this 4 pi on both sides. 4's gone, pi's gone. I've got r over 4 pi equals s squared. Now I've got to get rid of this squared exponent, so I will do the inverse. I will do a square root on both sides, and I mean the entire side. That whole messy fraction is under my square root. And then I've got my square root squared exponent. Those are inverses gone. Okay. So here is, I'm going to put the little inverse function, it looks like an exponent -1, but it means it's your inverse. All right, so there's the inverse. And then part B says to find the radius of a sphere that has a surface area of 100 pi square feet. So if its surface area of 100 pi is going to go in for the S. So I get a 100 pi equals 4 pi r squared. All right, so I'm going to pretty much do the same steps that I was doing up here. I'm going to divide the 4 pi on both sides. Okay, so I'm down to, let's see, the pi's divide out. I'm down to a 25 equals r squared. And I will take the square root on both sides, very similar steps here to get the r by itself. And square root of 25 is 5. So it looks like the radius, the r, is 5, and we were talking square feet, we're talking in terms of feet. So then we're talking 5 feet for the radius as far as the units go. All right, there we go.